3-1 to 3-2, calculators are allowed. This is number 9. Number 9, this one is going to test whether or not you can interpret words into mathematical statements. So if we look at this, it says the rate of change at x equals c. So this is representing f prime evaluated at c. We need it to equal, because is means equal, 3 times, so 3 times its rate of change at x equals 2. So that would be f prime with a 2 plugged in. So we're going to be setting up equations that look like this, and then we're going to solve for c. So let's look at part A. Part A, first we want to take the derivative, and we'll get a 4x. Then we want to determine what is f prime of c. So f prime of c is 4c. We also want f prime of 2. So f prime of 2 is an 8. Now we're going to set up this equation that says f prime of c is 3 times f prime of 2. And then we solve for c. You can say that c equals 6. So let's do the same thing with b. b is a little trickier. The first thing I want to do is rewrite that as a power of x. Makes it easier to take the derivative. So now my f prime of x will be a negative 6x to the negative 3. My f prime of c will be a negative 6 times a c to the negative 3. And my f prime of 2 will equal a negative 6 times a 2 to the negative 3. So if I set up my equation now that I want to solve for c in, I will have negative 6 times c to the negative 3 equals 3 times the f prime of 2, which is negative 6 times 2 to the negative 3. So my goal is to isolate c. This becomes an algebra problem. Probably what I would do first is I would try and simplify this and get rid of all my negative exponents, because negative exponents always make me just a little bit nervous. So I'd have a negative 6 over a c cubed, and on this one I'd have a negative 18 over a 2 cubed, which is an 8. So now if I cross multiply, because my goal is to isolate c, I would multiply negative 6 times 8 and negative 18 times c cubed. Then I will move the negative 18, so I'll have a negative 48 over a negative 18 equals c cubed, and then I'll need to take the cube root. So I have the cube root of, now let's look at what's actually happening here. Those are going to cancel. It'll end up being positive. I have a 6 times an 8. Well, that's a 3 times a 2 times a 2 times a 2 times a 2. That's on top. And on the bottom I have an 18, which is a 3 times a 3 times a 2. So if I reduce here, I'm going to lose a 2, and I'm going to lose a 3. Notice inside I've got 3 2's, and on the bottom I have 1 3. So we could write that as c equals a 2 over the cube root of 3. And if this were a free response, we could stop there and be perfectly fine. However, on the answer key, I think I took it a little further. So what I did on the answer key is I rationalized this denominator. So that means we've got to think about, what do I need to multiply by that equals 1 that will help me get rid of this cube root of 3? I don't want to have a radical in the bottom. So in order for a cube root to disappear, I need to have the same factor inside 3 times. So that means I'm missing 2 of those 3's. So if I multiply that out, I will get a 2 times the cube root of 9 on top, and a 3 times a 3 times a 3 cube root would be a 3. So last one, let's look at c. Same process. We want to have f prime, which is 15x squared, so that I can plug in f prime of c. That's a 15c squared. And I also want to plug in an f prime of 2. So that's a 15 times a 4 is a 60. Now, based on this statement here, we want f prime of c to equal 3 times f prime of 2. So c squared equals 3 times 60 over 15. Well, that's 3 times 4, which is 12. So c is plus or minus the square root of 12, which is plus or minus 2 root 3.